All right, now that we have our molecules drawn out, we can figure out what the shape is of that molecule. And to do so, we're going to use an AXE chart. What an AXE chart does is it gives us a shortcut method in order to find out the shape of the molecule. So the A stands for the number of central atoms. There's only ever going to be one central atom. So the A is always going to be 1. And in this class, we're still going to put an A and we're going to give it a subscript of 1. The X is the number of atoms that you have attached to the central atom, however many sticks you have used to create the bond that attaches the central atom when you make your skeletal structure. And E stands for the number of extra electrons that you have that are on the central atom. So your unshared electron pairs, those extra electrons that we put on our central atom when we finish distributing all of the octets. All right. And there is a chart, a handy dandy geometric hybridization patterns chart that you'll look at, and it will help you determine the shape. In college, you have to redraw your molecule in the shape that it ends up. But here, all you have to do is tell me what shape you think it's going to be, because it does take quite a bit of time to then redraw all your molecules. So in the interest of time, you'll just tell me you know what the shape is, and you don't have to redraw your molecule. The first one is an example that we've already drawn out the geometry for it. So we've got our molecule. There is one central atom, the Cl. You've got 4 atoms bonded to the central atom, these 4 oxygens, and you don't have any extra pairs of electrons on your central atom. So your AXE is a 1, 4, 0. So you come over to your handy dandy chart, and you're looking for a 4, 0, because the A is always 1. It's not even listed here on the chart. So the 4, 0 makes this molecule tetrahedral. All right, so you would just say the shape of this molecule is tetrahedral. By the way, this shape is tetrahedral, with it being at north, south, east, and west. And at the end of this PowerPoint, I'll show you some of the actual geometric shapes. All right, so our next one here that we have is we have one central atom. We have 4 things bonded to the central atom, and we have 1 extra pair of electrons on the central atom. So that makes me have a A of 1, an X of 4, and an E of 1. Please notice that I have an E of 1 because it's pairs of electrons. So I have 1 pair of electrons. And of course, you know, a pair means 2 electrons. So those 2 electrons equals 1 pair. So I've got a 1, 4, 1, and that makes a distorted tetrahedral. Now, this is not drawn here in the shape of a distorted tetrahedral. You would had to have brought these 2 BRs away from those lone electron pairs. But all you have to do is let me know that you know it's distorted tetrahedral, and we're all good. You do not have to redraw your molecule. I will show you a 3D image of what a distorted tetrahedral is later in this presentation. All right, so what's the AXE for this molecule? Look at the structure that you have. All right, so I have 1 central atom, the Br. I have 3 elements, 3 I's bonded to the Br. And I have 2 unshared electron pairs, one over here and one over here. When you look up your 132, your 132 is going to be T-shaped. Okay, so these 2 electrons would actually come over here on this side of the Br, and the rest of your molecule would be here correct. So this is almost T-shaped, except these lone electrons would be over here on this other side. But you can leave them right there as long as you tell me that you know a 132 is T-shaped. All right, so go ahead and figure out the AXE for this molecule and its corresponding shape. Pause the video. After determining the AXE, restart the video and tell me the shape. All right, one central atom, the Cl. Two atoms bonded to the central atom, the two O's. Two extra unpaired electrons on pairs on the central atom. So I've got an AXE of 1, 2, 2. So a 1, 2, 2 is bent. Okay. In college, once you found out that that molecule was bent, you would redraw it to look like that. This is what a bent molecule would look like. Once again, once you just, in here, you just need to tell me that you know it's bent. All right. So what about this one? That's an A of 1, an X of 2, and an E of 0. A 1, 2, 0 is linear. This molecule has been drawn here, linear. All right, so these are some of the geometric shapes. So they're letting you know the A is the red ball in these diagrams. The X is the extra electron, the things bonded to the molecule, and the E is your extra electron pairs. You'll notice that they've created this big cloud around it because extra electron pairs are more negative than something bonded to a molecule. So they create a cloud that pushes a molecule off kilter. So you've got linear molecules where the two things are 180 degrees away from each other. And they would look like this. You've got an A, two X's, and there's no extra electrons on this. So that's an example. Those are molecules that have the example of being linear. You have trigonal planar. If something's trigonal planar, everything has 120 degrees between them. This is what a molecule that you would draw out would look like if it was trigonal planar. That's the shape right there, trigonal planar. The examples of molecules that end up trigonal planar are these. You can also have something that's bent when you have the third spot being held by lone electrons. So it will be a bent shape if you have the central atom, two things bonded to the central atom, and one pair of extra electrons. Now you'll notice in this method they've not put ones in, but for us, we are always going to put our ones. You'll notice when they didn't have electrons on this other one, I'm going to circle it for you so you know, don't do this, okay? We are going to say E of 0, and we're going to have our ones in there. So do not do it in this method. This is not the method according to your textbook, okay? So you have to follow that method that I'm teaching you in all those slides. Do not do this method that you see in this. These are out of a college textbook. So examples of things that are going to be bent. Oh no, those are the trigonal planars. They didn't show you the bent. It's like they didn't give you examples of the bent one. This is what a tetrahedral looks like. Okay, looks like this. When you draw it on paper, a tetrahedral will look like this. When you redraw it, your tetrahedral kind of looks a little bit like a tripod with stuff sticking out of it. So you do not have to redraw any of your molecules. You just leave them looking just like they are and tell me that you know it's tetrahedral. These pictures that I'm showing you now are just for illustration, right? So those are bent. These are trigonal pyramidal. We've got trigonal bipyramidal shape. We've got seesaw shaped. That's also sometimes called distorted tetrahedral. This is T-shaped. This is linear. It's going to be linear. It's going to stay straight because these extra electrons are all counteracting each other. This is octahedral. This is square pyramidal. is a square planar, and you do not have to know